I know the formula for this. But the question statements are really confusing. Stretched the wire, doubled on itself, and so on. How to solve these?
Don't worry. Let's see all possible types of questions. Let's solve an easy question first. A wire of given material having length L and area of cross section A has a resistance of 4 ohms. What would be the resistance of another wire of the same material having length L by 2 and area of cross section 2A? Consider the first wire having length L and area A. Resistance R is equal to 4 ohms. The second wire has length L by 2, area 2A, and resistance R dash we have to find. The formula is R is equal to rho L by A. For the first wire, resistance rho into L by A is equal to 4 ohms. Another wire has L dash is equal to L by 2 as given in the question. A dash is equal to 2A. Both wires are made of same material means they have same resistivity. Resistance of the new wire R dash is equal to rho into L dash upon A dash. And we are substituting the values of L dash and A dash in this equation. We will get the resistance of the new wire is equal to R by 4. 1 by 4th of the resistance of the first wire. That is R dash is equal to 1 ohm. Now let's see the next question. If a wire of resistance R is stretched to double of its length, then find the new resistance of the wire. Here the key word is stretched. We are stretching a wire to double length. Consider the original wire. Now we are stretching a wire means its area is decreasing without change in volume. That is A dash we don't know, but L dash is 2L. And we have to find the resistance of the new stretched wire. While increasing the length by stretching a wire, remember its volume remains constant. Volume is equal to pi r square h or area of cross section into length. That is a constant. So area into length before stretching will be equal to area into length after stretching. From this, we can find the new area. We know the equation. Resistance of the wire R is equal to rho L by A. That is the resistance of the wire before stretching. When it is stretched to double length, L dash is equal to 2L. Volume before stretching is equal to volume after stretching. From this formula, we can find A dash is equal to AL divided by 2L, that is A by 2. Means when we stretch a wire to double length, its area will be halved. Now we can substitute the values. Resistance of the stretched wire R dash is equal to rho into L dash upon A dash. While substituting, we will get 4R. Means if we stretch a wire to double its original length, then the resistance will be increased by 4 times. Now let's see the third question. If a metallic wire of resistance R is doubled on itself, then calculate the new resistance of the wire. Here, the key word is doubled on itself. What will happen if a wire is doubled on itself? Let's see. Consider the original wire, and while a wire is doubled on itself, its length becomes half and area becomes 2 times. L dash will be equal to L by 2, A dash will be equal to 2A. Resistance of the wire R is equal to rho L by A. When it is doubled on itself, A dash becomes 2A, L dash becomes L by 2. Then the new resistance of the wire is R dash is equal to rho L dash upon A dash. By substituting the values of A dash and L dash in this formula, we will get R dash is equal to R by 4. Means a metallic wire of resistance R is doubled on itself means its resistance will be 1 by 4th of the original resistance. The next question, a metallic wire of length L has a resistance R. What will be the resistance of a wire of same length and same material if its radius is doubled? In the question, it is given that the radius of the wire is doubled, but it has same length and it is made of same material. This is the original wire having length L and radius R. Its resistance is capital R. Consider the new wire in which its radius is doubled but length remains the same. Consider its resistance as R dash. Area of cross section of the wire A is equal to pi R square. We need to use this because in our formula R is equal to rho L by A. We are putting the value of A. When the radius is doubled, R dash will become 2R. Area of cross section in that case, that is A dash is equal to pi R dash square, that is pi into 2R the whole square. Means the new area will be 4 times pi R square, that is 4A. Resistance of the wire R is equal to rho L by A means the resistance of the original wire before doubling the radius. When the radius is doubled, A dash becomes 4A, L dash is remaining as constant. Then the new resistance of the wire R dash is equal to rho into L dash upon A dash. Here rho is also constant because we are using the same material. While substituting the values of A dash and L dash in this equation, we will get R dash is equal to R by 4. Means if the radius of a wire is doubled without changing the value of length, then the new resistance will be 1 by 4th of the actual resistance. See the next question. A piece of wire of resistance R is redrawn without change in volume so that its radius is doubled. Calculate the new resistance of the wire. Here, the key word is redrawn without change in volume. Consider the original wire having length L and radius R and resistance capital R. The new wire has length L dash, radius doubled means 2R, and the new resistance is R dash. Here we have to find the value of L dash, new length also, because in the question it is mentioned that without change in volume. That means if area is changed, obviously its length will also be changed because volume is constant. Area of cross section of the wire A is equal to pi R square. When the radius is doubled, R dash is equal to 2R. Like in the similar question, the new area will be 4 times the area of the first wire. Now, the resistance of the wire R is equal to rho L by A. When it is redrawn to double radius, its volume remains constant. AL is equal to A dash into L dash, as we have already seen. Here, A dash is 4 times area of the first wire. While substituting, we will get L dash is equal to L by 4. The new resistance of the wire is R dash is equal to rho into L dash upon A dash, that is R divided by 16. Means if a wire is redrawn without change in volume and its radius is doubled, then its resistance will be decreased by 16 times. Resistance becomes R by 16.